All right, we're back. Let's do another problem. So as you can tell, I have printed these out. This is normally what I would be teaching on the smartboard. Find the volume of the solid that is obtained when the region under the curve y equals square root of x over the interval 1 to 4 is revolved about the x-axis. If you need to pause the video and write it down, do that now. We'll start with sketching this out. Y equals square root of x is a radical rocket. It starts at the origin and it kind of shoots off in a gradual growth pattern. So when we look at this, we're going to begin this region at x equals 1 and we will end this region at x equals 4. So we'll begin rotating at 1, 1. And we'll end rotating at 4, 2. Because when you plug in 4 to square root of x, you get 2. Okay, same thing with 1. So this is the region that will rotate, which means that it's going to get reflected across the x-axis like so. Okay, so if it gets reflected, this is the bottommost part of the volume. And since we're rotating, we're going to be revolving, it's going to be making circles. Okay, it's going to circle around the x-axis over and over and over again. So each of these circles, and by the way, this is a favorite one of teachers. The reason this is our favorite one is probably going to become obvious in a second, is because the area of each of these circles is going to have a radius that starts at the x-axis and goes up to this function. So this height here is determined by the square root of x, which means that the radius is going to be the square root of x for every single x value along this pattern. So each circle will have an area of pi r squared. In this case, pi square root of x squared, which is just plain old pi x. See, that's why we really like rotating the square root of x. So here's my radius, here's my area, here's my volume. The integral of the area. In this case, that's going to be from 1 to 4, because that's what I've been told, over the interval 1 to 4. And then the area, just going along right here, pi x dx. So if I find the area of one circle, that's great. But if I find the accumulation, which is the integral of all the areas, then I have found the volume. And this is going to be pi is a coefficient, x squared over 2 from 1 to 4. So pi times 16 over 2 minus 1 over 2, right? 4 squared over 2, 1 squared over 2. So 16 minus 1 is 15, so I just call this 15 pi over 2, and I'm done. Yay! All right, pause here. Next video coming up.